Hello, my amazing students. This is Mrs. A, and I love math. I also just dropped my math book. That was that big noise. We are doing lesson 25, and it is solutions of equations. So this is where algebra really starts to get fun. Okay, so we have two big rules that we're going to use in solving equations, which is finding the solution that makes it true. Okay, so the addition rule of equality, your book doesn't actually call it that, but as you move on through algebra, most books call it that. It's the addition rule. The same quantity may be added to both sides of the equation without changing the solutions or the answers. Okay, so you might want to copy that down. That is your number one rule, and then your number two rule is this one, and it is called the multiplication property of equality, and it says that every term on both sides can be multiplied or divided by the same non-zero quantity without changing the answers to the equation. So that's your second big important rule. Now, something to understand is that in many equations we will use one or both of these to obtain the solution. We can have either just the addition or the multiplication, or we might have to use both addition and multiplication to finally get our x or our variable all by itself. But we're going to notice that the order is different than order of operations. Order of operations, remember, let's review, is parentheses, brackets, braces, absolute value, anything that is a symbol of inclusion or a parenthesis type grouping symbol. Okay, we do those first, all right? So please excuse my dear Aunt Sally. So please is parentheses, brackets, braces, all those inclusions. We do those first in any equation. Then the second one is E. Please excuse. It also stands for exponents and roots. So we'll do exponents and roots second in our order of operations. Now you haven't dealt a lot with roots yet or with exponents, but those come second in the list of the order in which we attack an expression. Okay, then please excuse my dear, multiplication and division are at the same level of importance, and they come before Aunt Sally, addition and subtraction. Okay, so please excuse my dear Aunt Sally. There's 6 and parentheses, brackets, braces, exponents, multiplication and division, addition and subtraction. That's the order in which we do them. However, when we are solving an equation, we're trying to get the x all by itself, and we go backwards on that order. We're going to use our addition rule, which is also the subtraction rule, because remember, subtraction is addition of the opposite. So we just add a negative number, and that's the same thing as subtracting, okay? And then we multiply and divide after we've added or subtracted. So we're going to see some examples of that. Okay, so here we have 3x minus 2 is equal to 10. When we're solving these, we always want to get the x term by itself before we worry about getting the x itself alone. Okay, so here is my x term. So we're wanting to get rid of the negative 2. We get rid of the negative 2 by adding 2 to both sides. That is my addition property of equality. So now I bring down the 3x, I cancel the negative 2 and 2, and I get 12. So now we're ready to apply our multiplication or division property, which dividing by 3 and dividing by 3, I'm going to draw a little line here between the two problems, and I end up with x equals 4. Now, to check and see if I indeed got the right answer, I take the 4 back up into the original. 3 times 4 is 12. Take away 2 is 10. Therefore, It checks. Okay, let's go with your first real example. And I have one x term, which I want to get by itself. So I want to get rid of the plus 5, which means I'm going to subtract 5 from both sides. Whatever I do to one side, I must do to the other. So now I bring down my 4x. I cancel the 5's. And then on the other side, I have 17 take away 5 is 12. I divide by the 4 because it's with the x. I do the same thing on both sides, and I end up with x equals 3. So now I check. I take the 3 back into the original. 4 times 3 is 12 plus 5 is 17, and it makes the equation true. So the next example, okay, so I have a negative 5m plus 6 is 8. Here's my m term. I don't have an x term, I have an m term. It doesn't matter what the variable is, but I have a 6, and I'm trying to get the m term by itself. So I'm going to subtract the 6, but I'm going to do the same thing from both sides and get negative 5m cancel equals 2. Okay, this one's not going to come out to be a whole number, is it? All right, I want to get the m by itself, so I'm going to divide by a negative 5 and divide by a negative 5. Draw my line. Okay, this is going to cancel, and I'm going to get m equals 2 over negative 5 is the same thing. A positive divided by negative is a negative, so I'm just going to put the negative out front. So negative 2/5. We don't usually leave a negative sign in the denominator. It's just considered poor form. Okay, we want to leave it in the best form. We will have the minus sign on the top or out front. And this is another one. We have negative 7k is our variable term. We have a minus 4, which we want to get rid of, so we will add 4, add 4. We get a negative 7k. This goes away. Negative 24 plus 4 is going to be a negative 17. Not going to be a pretty answer, is it? So we're going to divide by a negative 7 to get the k by itself. Divide by a negative 7 over here. I'm out of room. These are going to cancel, and I will get k equals. Now, negative divided by a negative is a positive 17 sevenths. Okay, so that's the answer. Now, if we go back into here and we plug in our 17 sevenths, the negative 7 times 17 sevenths, let's just throw them in there so you can see it. The negative 7 and the 7 will cancel, leaving a negative. Negative 17 minus another 4 is a negative 21. We didn't check this one. Okay, so if we plug up here for the m, we plug in the negative 2/5. Then the negative 5 and the 5 will cancel, leaving a negative. Negative and negative 2 is a positive 2. 2 plus 6 is 8, and it works. Okay, so we can always plug them in, and especially on a test or a quiz, you would definitely want to plug them in, wouldn't you? Okay, so here is our next example. Here is our variable term. We want to get rid of the plus 5, so we will subtract 5, subtract 5. We will get negative 11p, cancel, is 12. This one's not going to be pretty either. So we're going to divide by a negative 11, divide by a negative 11, and p is 12 elevenths with a negative in the front. So negative 12 elevenths. And if we plug it back in here, we're going to have the 11s cancel with a negative. 1 times a negative 12 is a 12, plus a 5 is a 17, and it checks. All right, this one I'm going to work for you 2 ways. Okay, so yes, we're going to get rid of the 1/2. So we add a 1/2, and we're going to add a 1/2. Okay, so we end up with 1/5 m. This cancels. And since I'm adding a 1/2, can I call that 1/2 a 2/4? Because remember, I have to have the same denominator to add fractions together. So instead of 1/2, I'm going to call it a 2/4, and I'm going to add it to the 3/4 to get a 5/4. Okay, so now look at what I have. Since I have a 1/5 in front, can I just multiply both sides by 5? Okay, if I have a fraction I can multiply by its reciprocal, which would be 5/1, or 5. So I'm going to multiply by 5 and multiply by 5. Okay, so I'm going to get, this cancels, m equals 5/4 times 5 is 25/4. Okay, now we would usually leave that in its improper form unless we were told to turn it into a mixed number, because all of our other numbers are in fraction form. Okay, so as a mixed number it would be what? 6 1/4, right? But we don't have any reason to turn it into a mixed number unless they tell us to, because in algebra, improper fractions are allowed. Okay, so that's how you would work that problem. And they do give you, as an answer, they give you 25/4. Now I'm going to show you one more way to work that problem that can end up being an easy fix for those fractions that are bothering you. Okay, now we're going to work the same problem, but we're going to use another method that is a simplification technique that a lot of mathematicians will use just because it's easier not to deal with those fractions. So remember, we got 25/4 the first time through, and we're going to get 25/4 this time, but we're going to do it just a little bit differently. Okay, now remember, the 2 rules mean that I can do both addition property or multiplication property anytime I want to. When we're solving a problem that has them both, we usually use the addition and then the multiplication. However, if we want to clear the fractions, this is a secret you don't get to until a little bit later, you can multiply by the least common denominator. The least common denominator is the smallest number that 5 and 2 and 4 will go into. And the least common denominator would be, okay, 2 will go into the 4. So 4 and 5 multiplied together gives us 20. So the least common denominator is 20. What happens if I multiply both sides by 20? So I'm going to multiply every single term by 20. Watch what happens. 20 times 1/5 will be 4m. 20 times 1/2 will be 10. And since it's a negative 1/2, it'll be a minus 10. 20 times 3/4 is 15. Now look what I did. I took my very complicated equation with lots of fractions and I turned it into a pretty simple looking equation. So here's my variable term. I'm going to add 10 and add 10. 4m is 25. Divide 4, divide 4. M is 25/4, which is what we got before, and which is the correct answer. So you can decide, do you like to add or subtract the fractions and then do the division, or do you like this method where you multiply everything through by the same least common denominator and you get the same answer without having to mess with fractions? Both of them are correct. It's just simply a matter of preference, which one you're going to use. Okay, the multiplying by the least common denominator is considered a simplification step. You're not really changing anything, just the forms of the numbers. And so it makes it easier because it gets rid of the fractions. Okay, so now we're going to do one with decimals. Okay, and here is my variable term. So we're going to add a 0.2 and add a 0.2. This is going to cancel. We're going to bring down our 0.4x. And over here on the right, we have a negative 0.16 and a positive 0.2. But remember, the 0.2 is 0.20 because we like to line up our decimals. And so now I have 0.20 minus 0.16, which is going to be a 0.04. Okay, so now I'm going to divide by 0.4, and I'm going to divide by 0.4. Okay, this is going to cancel, and this is going to be my answer. But remember, when I divide, I don't want a decimal in my divisor. So I'm going to multiply by 10 and multiply this one by 10. So now I have all these zeros. These zeros can be a little bit confusing, but I have a 0.4 divided by a 4. And a 0.4 divided by a 4 is simply going to be a 0.1 or 1/10. Okay, so we're going to say that the answer is 0.1. Now, we're going to do the same thing we did on the last problem, which is multiply, instead of by a least common denominator, we're going to multiply by a power of 10. It's the same problem, but I'm going to simplify, clearing out the decimals before I do the math. So the first thing I look at is say, okay, I have 1 decimal, 2 decimals. To clear the 2 decimals, I have to multiply by 100. Therefore, I'm going to have to multiply by 100 in each individual term. So if I multiply this one by 100, it's going to move the decimal place 2 places to the right, and it will be 40x. I multiply this one by 100, moving the decimal 2 places to the right, and it will be negative 20. I multiply this one by 100, moving it 2 decimals to the right, and I'll have negative 16. So now I have a 40x. Let's add a 20 and add a 20. 40x cancel equals 4. Okay, so now I'm going to divide by 40. I'm going to divide by 40. And I'm going to get x is divide by 4, 1/10. And since we started with decimals, we usually end up leaving the answer in decimals, which was 0.1 is 1/10. Okay, so that's doing it with the decimals there, and that's doing it with the multiplying by power of 10, which is also a simplification method. Okay, so they'll be showing you that pretty quickly, but I wanted to show you it now because there's no reason you can't start using it when you want to. It's equivalent to what they're doing here. It's just simplifying a little bit using your multiplication property of equality. Okay, so here we're going to move into our practice problems. Okay, so here's your first practice problem, A. Now, we could do this by multiplying everything by 10 and clearing out the fraction. But since they haven't shown you that yet, I'm going to go ahead and do it using keeping the fractions there. Now, I want you to be able to do these by yourself without watching me. So, I want you to pause your video and go do it yourself before you come back and see the answer. Okay, so now we're going to take this and get rid of it. We want to keep this by itself. So we're going to add a 3/10, and we're going to add a 3/10 on this side. Okay, so we're going to bring down our 2/5 x. This cancels. And then I'm going to change my 1/2 to 5/10 because I need a common denominator. My other denominator is 10, so I'm going to multiply by 5 and 5 to get 5/10. 5/10 plus 3/10 is 8/10. Okay, so now I'm going to get rid of the 2/5 by multiplying by its reciprocal, but I'm going to do it on both sides. So I'm going to multiply by 5/2 times 5/2 on this side, and we get x equals. Now, wouldn't it be nice if we just went ahead and canceled a little bit here? We can cancel the 10 and the 5, leaving a 2 and a 1, the 8 and the 2, leaving a 4 and a 1, and lastly, we have 4/2 is 2. Okay, now let's check it. Let's go back to the original and let's plug in a 2. So I'm going to make this a 2/1 just so that I can see what's going to happen. And I'm going to get a 4/5. But a 4/5, I got a 10th here. So 4/5 is 8/10. Take away 3/10 is 5/10, which is 1/2. And we got it right, didn't we? Okay, so now we're going to do the second example, which has a mixed number in it. Because there's a mixed number in it, I will leave my answer as a mixed number if it has an improper fraction at the end, because I see a mixed number in the problem. Therefore, I assume that as a mathematical convention, I usually leave the answer in the form I see the problem in. So I see this mixed number. But in order to do anything with it, I'm going to have to turn it into an improper fraction. So 2 times 4 is 8 plus 1 is 9. So that's 9/4 x plus 3/7 equals 5/14. Okay, I'm going to subtract the 3/7 and subtract the 3/7. This is going to cancel. 9/4 x equals. Now, since I have a 14th and a 7, I'm going to have to get like terms. So I'm going to, like denominators, I'm going to multiply by 2/2. And that's going to give me a -6 on the top and a 14 on the bottom. So I have 5/14 minus 6/14 is -1/14. So now I have to get the x by itself. So now I'm going to apply the multiplication rule, and I'm going to multiply by the reciprocal of 9/4, which is 4/9. Over here, 4/9. These cancel. X equals negative. Now, I can go ahead and say that's going to divide by 2 and divide by 2. Can't I do that? So -2/63. -2/63. So, how do we know if we got it right? Okay, so we could go back up here into, now see, this one is the same, 9/4. I'm real sure that's 9/4. So I'm going to go -2/63 right here, just to check it. Okay, so now remember that 9 and 63 will cancel with a 7 and a 1. Okay, and then I've got, since this is 14ths, I'm going to make this 14th, so I'm going to leave this one as 14th. So I want to go ahead and cancel the 4 times the 7. I'm going to cancel this as a -1 and this as a 2. So now I have 14ths in the bottom, and I have a -1/14 there. This one, because it's 3/7, isn't that the same as, let me move this over here, multiply by 2 on the top and the bottom, wouldn't I get 6/14? So let's change that to 6/14. -1/14 plus 6/14 is 5/14. And that's true, isn't it? So that was your second practice problem. How did you do? Did you pause your video and do it yourself? I hope you got it right. Here we have our third practice. 1.2 equals negative 1.4 plus 20x. So we're going to get this by itself. Now we have our x on the right, and we have our equal sign way over here on the left. So don't we want to get this by itself? So we're going to add a 1.4 to both sides. Okay, so now this becomes a 2.6 equals, these cancel, 20x gets brought down. So now I'm going to divide by 20 and divide by 20. This cancels. Now I don't like my x on the right. I'm a little bit OCD about that. So I'm going to move my x on the left, and then this is 2.6 divided by 20. Okay, so now I'm going to do that division. So if I divide 2.6 by 20, then I'm going to have my decimal place right there. It's going to run right up because there's no decimal place in here. So I'm going to have 20 does not go into 2, so that's my 0. But 20 does go into 26 one time. Okay, so 1 times 20 is 20. 6, 0. 20 goes into 60 3 times. So it'll be 0.13. Okay, so could we check that? If we went back up here, we had 1.2 is equal to negative 1.4 plus 20 times 0.13. Okay, so 20 times 0.13. Well, I know that 2 times 13 is 26, so I know my answer is going to have a 26 in it. But doesn't this 0 move that decimal over 1? So I could do this, 1.3 times 2, so that's 2.6. Okay, so I have a negative 1.4 and a 2.6. 2.6 minus 1.4 is 1.2, and that equals 1.2, and it checks. So my answer is 0.13. How did you do on your problem? Did you pause your video and do it yourself before you looked at the answer? If not, I hope you do it on this last one. Last problem in lesson 25. Okay, so we've got 0.7x minus 0.4 equals 0.16. This time, since I just did one with decimals in it, I'm going to go ahead and move these decimals by multiplying. This is 1/10, this is 10th, hundredths. So I need to multiply by 100 to clear all the decimals. So I have to multiply each term by 100. If I move this decimal place 2 places over, multiply by 100, I get 70x. I multiply this one 2 places over, I get minus 40. And I take this one and move it 2 places over, and I get 16. Much simpler to look at. So now I'm going to add a 40 and add a 40. And I'm going to get 70x equals 56. X divided by 70, divide by 70. X equals 56 over 70. Okay, so now we know that 7 times what is 56? 7 times 8 is 56. Okay, so if we didn't have that 0 there, the answer would be 8. But since we have the 0 there, the answer is 0.8. So let's go back and check it. If we plug in the 0.8 right here times 0.8, what happens when we have a 0.7 times a 0.8? Don't we get a 0.56? So 0.56 minus 0.4, but remember 0.4 is 0.40. Isn't that going to be equal to 0.16? And it checks. And we are done with lesson 25. And this is Mrs. A, and may God bless your day.